50 is on areas in the plane. So we're going to have areas that are going to go below the x-axis now. Previously, we've always talked about the areas above, like when f of x is positive, so we're going to have above and below. So it says, suppose we have the sketch below, and we want to find the area between the curves f of x and g of x from a to b. How do you think you would find it? How would you guys set this up? Ian, what do you think?
Would you find the integral of f of x for that section, and the integral of g of x for that section as if it were above the curve, then you add them together?
Okay, so when he's saying g of x is as if it was above the curve, he's kind of doing like a reflection across the x-axis, so making it negative, and then adding that to the other piece?
Yeah.
Does that make sense? Do you guys understand what he's saying? So he's saying this second part, you would flip it over and become negative g of x. You would find its area, and you would add that. So you'd have this positive value and this positive value added together. Exactly. Do you understand that concept? All right, so the way that we do this then is we write f of x minus g of x, because that's what it is, negative g of x added to f of x, dx, going from a to b. Okay, so let's think about some real-life distances, because really if I'm finding an area, aren't I just finding, do you guys remember those rectangles that we had when we found the infinite number of rectangles and we added their heights times their widths, added all of those all together? So if I had a rectangle and I wanted to talk about the height of that rectangle, let's say the height here was 7 and the height here was negative 3. How do I find the height between 7 and negative 3? It's 10, right? We all know that. We know that it's 3 that was below and 7 that was above, so it's a total of 10. Do you guys see that this is the same thing? 7 minus a negative 3 is 10. Does that make sense? So does it work when it's above or below? So let's say we had both of them above and we were at 8 and 2. Does the top minus the bottom still work? 8 minus 2 is 6? It does. How about if they were both below? So negative 2 and negative 6. If I do negative 2 minus a negative 6, what do I get for that height? 4. Is that the height between those two distances? It is. So what we're always doing is we're taking the top and we're subtracting out the bottom. So it doesn't matter if one curve is exclusively above or if one curve is exclusively below. It doesn't matter. One can go above and one can go below. It doesn't matter. It's always the top curve minus the bottom curve. So how could this get difficult for us? Yeah, 80.
If it crosses the x-axis.
What if they cross? What if the top curve then becomes the bottom curve? What if it doesn't just cross the x-axis, but what if they cross each other? Calculus. All right, so let's figure it out. So the area between the two curves is the formula that I wrote. So it's the top curve minus the bottom curve going from A to B. And we're also going to do curves that are on their sides, like parabolas that are on their sides. So not functions, right? But parabolas that are on its side. We're still going to do it. And in that case, we're going to have, what if I had 10 here and negative 2 here? What's the distance? 12. How can we find it? Not top minus bottom, but right minus left. Then we'll do right minus left for those ones. Okay, so it's all going to be interconnected. All right, so let's try some examples. So it says find the area of the region bounded above by y equals x squared plus 1. I do expect you to know how to graph y equals x squared plus 1 without putting it in your calculator. It's shifted up 1, and it's a parabola. And it's bounded below by y equals x. Oops, missed it. So y equals x. And we're going between 0 to 1. So the area created has a parabola along the top and a line on the bottom. So I don't know what shape we would call that. But it looks like that. I got a little crazy there. Okay, so we want to know how to set this up. Well, we just said that it's going to be the top minus the bottom, right? And we're going to go from A to B. So we're setting it up just like that. Our area ends up being the top curve, which was x squared plus 1, minus the bottom, which is just x. And we're going from A, which is 0, to B, which is 1. Done. Do we like that? Do you know how to integrate that by hand? 1/3 x cubed plus x minus 1/2 x squared. Going from 0 to 1. This one is actually much faster to do without a calculator, I feel like. I think you guys can do this one without a calculator. Do we agree? So we have 1/3 plus 1 minus 1/2. And then the second part is 0. So 1/3 plus 1, so 4/3 minus 1/2. 4/3 minus 1/2. Do you guys remember that trick I taught you at the beginning of the year? For subtracting these. You can get common denominators. So you can do 4 times 2, which is 8, minus 3 times 1. So 5 over 6. You can do that as well. Do you guys remember that? At the beginning of the year, you guys were like, why hasn't no one ever taught us this? All right, so we're going to get 5/6 then is the answer. And basically what it's doing is it's getting common denominators. It's just not writing it all out. It's 8 over 6 minus 3 over 6, right, which is 5 over 6. Okay. Feeling pretty good about this? It obviously gets harder. Some of them are going to be pretty hard. All right, so find y equals 3 minus x and y equals x squared minus 9. So again, do you guys know what these sketches look like? So x squared minus 9, we know it's shifted down to negative 9. And it's a parabola. Where does that parabola cross the x-axis?
3 and negative 3.
3 and negative 3. Do we all see that? And then we have y equals 3 minus x. So I'm going to rewrite that as y equals negative 1x plus 3. So we know it has a y-intercept of 3. And it goes down 1, right 1, down 1, right 1, down 1, right 1. So it's also going to cross at 3. Do you guys see that it's going to cross on the x-axis at 3? But the other place that it's crossing, we don't know. Who knows the answer to this question? How do I find the intersection point? How do I find that point up there where it's crossing? You could plug it into your calculator, but what if it's on the 2/3 of the AP Calculus exam that you can't use a calculator on? You just cry? You know what? My Algebra 2 class is actually doing this today, weren't they? Mr. Moss, he witnessed it. He saw them doing this. A parabola intersecting a line.
Systems of equations.
System of equations, that's right.
I will give credit for that.
So we're going to take y equals 3 minus x and we're going to replace it in here, right? So we're going to have 3 minus x equals x squared minus 9. So I get x squared plus x, right, add it over. And then I subtract my 3 over, I get negative 12. And we factor. Nothing to cry about. You guys can totally handle this. So x plus 4, x minus 3. So we get x equals negative 4, and we had x equals 3. Well, the x equals 3, that was right here. That was that point 3 comma 0. So we're good there.
Negative 4 is where they intersect.
So negative 4 comma what? How do I find that y value?
Yeah,
Go
so
back
negative
in.
4, 7.
Negative 4 comma 7. Good. Do you guys see? So he went and plugged it into 3 minus a negative 4, so 3 minus negative 4 is 7. Because the 3 was actually this one. It gives 2 answers. It's this and this. Okay, so we already had the 3 comma 0 one. And you can plug in 3 into either equation. You'll get 0. All right, so we're trying to find the area bounded by these two graphs. So do we know which one's the top and which one's the bottom? Yeah, the top is the line, the bottom is the parabola, right? So when we set it up, we're going to have the area equals the integral from negative 4 to 3. Those are my two x values, right? The negative 4 to 3. And I'm going to have the top curve, which was 3 minus x, or you can write negative x plus 3, minus the bottom curve, which is x squared minus 9. And you can do this one by hand, or you can use Math 9. As long as you have this set up, I will let you use your calculator. So I should have found these for you already. Math 9, 3 minus x squared. I'll put plus 9, x negative 4 to 3. Do you guys get it? You guys are getting speedier, though. I hear you guys clicking away. Very nerdy of you. Click, 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 click. Did you get it? I got 343 over 6. Or if you found the decimal version, 57.16 repeating, so 167 I'd write. 3 decimals. Good? So 57.167 or 16 repeating.
And as equals 243 over 6.
343 over 6. Yeah. All right.
That makes a lot more sense.
This one's a weird one. I mess this one up every year, so I had to write a hint, not for you, but to remind myself that this one's weird. So I said, find the area bounded by the graphs of y equals x squared, so y equals x squared, and y equals 2 minus x squared. But then I said, on the interval 0 to 2. So every year that I do this one, I'm always like, oh, we're going to find from here to here, and we're going to do top minus bottom, but it's not actually that area that I just sketched in. Do you guys see what area it is? Nope, it's 0 to 2. But this intersection point, we're going to hope that's 2. Fingers crossed. Is it 2? It's totally not 2. So the intersection point, you can find on your calculator, like Ariana was saying, like you can find that by plugging in the first curve for y1, the second for y2, and finding the intersection point on there. Just make sure if you're finding an intersection point on the AP test, you write the equation that you're plugging in, basically. So you would have to write x squared equals 2 minus x squared in order to find that intersection point. If you don't do that and you just go straight to your calculator, you're going to miss points on your test. So you can find it. This one's not hard to do by hand, though. What is it? It's 1 plus or minus 1, right? So this is at 1. It's actually the point 1 comma 1, right? Because it was on x squared. So that means we're going all the way to 2. So it's a weird, I don't know, kind of like a fish shape, except the head of the fish is cut off, but you see its tail and part of its body. You guys see it? It's like that. So this is one of those situations where our top curve and our bottom curve have switched places. You have 2, exactly. So the first integral is going to be, what's the top curve for the first one?
X squared.
Not the x squared. Yep, the 2 minus x squared. What do you think would happen if you flipped them?
You get the negative.
You would. So if you ever, on your area homework that I give you, you will never have a negative answer. If you have a negative answer, you did it wrong, and then you just erase your setup, flip it, and then use that positive version, okay? That happens with volume sometimes too. Like people will mess up on the volume equations. They get negative. Know that area and volume are not negative, right?
So if it's negative, then it's most likely that you use the wrong.
Yeah, so sometimes I'm just lazy and I just do an absolute value here. Or actually I do an absolute value. Don't do it there. I would do it around the whole thing. But don't be lazy like me. Just switch it. So that way you get your points for your setup too.
From 0 to 1.
Yep, so the first one is from 0 to 1. And then the second integral is going to be from what? 1 to 2. And it's going to be the top curve is now x squared. It's this one. And then it's minus the 2 minus x squared. And you can simplify them a little bit if you want to before you put them in the calculator. So it would be 2 minus 2x squared dx. And then 1 to 2, 2x squared minus 2 dx.
So whenever you have like those different fixed widths, you're literally just gonna like write.
Yeah, like switch your top and your bottom.
The second one is just gonna be the opposite.
And I'm sneaky sometimes with this too, so I'll show you on my little calculator up here. So I don't like to type in a lot of Math 9 stuff, so I would probably do this one and I would do my Math 9, 2 minus 2x squared. And then I do my comma, x goes from 0 to 1. And I hit enter.
Do you add?
So I have that. Yes, and you can find that as a decimal too. Do we all know 1.3 repeating now? 4/3, yeah. So you can change it to a fraction if you want to. And then if your calculator doesn't let you go back up, see how I push the up button and it doesn't let me go back up? I can do second enter, clear, and then do second enter again, and it pulls up that last thing. And this is where I get really lazy. I just outsmart the system. So now I would just do from 1 to 2 and say, oh, that's going to give me negative 2 point blah, 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 blah. So I find that. So I had 4/3 and I have positive 8/3. Do you guys see why I was like tricky there? I didn't switch it. Or if you're really outsmarting the system, what could you do? So second enter, clear, second enter. Instead of 1 to 2, couldn't you just do 2 to 1? Do you guys understand why we can do 2 to 1? So we're flipping our limits of integration and we're making the whole thing opposite, right? So that way you don't have to type everything, especially if you have those really, really long functions. It saves you a lot of time. All right, so what did we get? 4 total?
Yes.
Well, that was nice. All right, so number 4. So it says find an approximate area. An approximate. So I'm guessing that we're going to have to store our values on our calculator. Okay, so to find the graphs bounded by y equals cosine of x and x squared. These types of questions are the ones that the AP test has gone to recently. They make you store your answers, and if you don't store them, the answer you get will be wrong because they make it so picky, like you have to store it because otherwise it's going to be off by a lot. We don't want things to be off by a lot, right? You're building my future bridges. We've talked about this. You've seen the picture of the bridge that doesn't meet up. Please build them correctly and store your values.
I have that bookmark sometimes I need a lot.
Oh, you do? I should send you the file of my math fails. All right. So we have this intersecting y equals x squared, and cosine does continue on this side of the axis. So, woo, that is not symmetric at all. Woo. Let me fix my drawing. So we're finding this little portion right in here. So our top is definitely cosine of x, and the bottom is definitely that x squared. Do we all see this? I think you guys know how to graph those, but this is a calculator problem anyway, so you could graph it. Sorry, did I cover it up? You want me to move it? So we have cosine of x, and it's in radian mode, and then we have x squared, and we graph.
We need to find the intersection points, right?
So ours is pretty zoomed in. We could use our Z-box if you want to zoom in a little bit, or you can just change the window. So I would think our window should be like much closer, -3 to 3 maybe. And then we'll go like, yeah, we'll do -3 to 3 for this one too. Let's see. A little bit better. Okay, so we can find those intersection points. Tell me why you know that it is symmetric. Why would it have to be symmetric? They're both what?
They're both already symmetric.
They are symmetric. Do you guys know the word? These functions are both, what's the word? Even. Oh, yeah, good. So these are even functions. So because they're both even functions, it's going to be symmetric. So really we just have to find one intersection point. So if I do second trace and I find my intersect, I'm going to go over to that intersection point, hit the thing 3 times, and I have 0.824, blah, 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 right? So I typically will store both the x and the y just in case if I was doing a free response question, because sometimes you need the y value as well in your free response. So if you go back to your main screen, second quit, and you hit x, it will give you the 0.824 number. I would write something like let a equal 0.824, and I maybe do a ... and then b, so if I need that one.
So how do you store the 0.824 number?
So I'm going to do stow as alpha a.
But you don't have the number, you just have the number in here. How can you get
So go back to your main screen, so do second quit, and then hit the x button, like your x t theta n.
Oh.
And then it comes up, right, that 0.824 number, and then do stow alpha a. So you can store the other value to the y value if you need to. So you would just do alpha y in order to get to it, and that gives you the other number that we had.
How do you get y up there? Oh, you
The
go
alpha button,
Y?
and it gives you that number that we just had. And then you can store that one just in case you need it. But in this example, we actually won't need it. But I'm just saying, in general, in the AP test, a lot of times you will need it. So that's going to be the 0.679 number. Whoops. Did I lose you, Ariana?
Sorry, like how do you get to the y?
Do alpha y, like the green button, alpha. And then y is down. It's numbers. What number is it? 1? It's above the number 1. Okay, so we have the x and we have the y. So when I set this up, if I've stored a, what I'm going to do is -a to a. Okay, you would get full points for this setup on the AP test, as long as you've written let a equal blah, blah, blah. The only thing I would caution here is you don't want to write a equals as in area equals. Do you guys understand what I'm saying? Don't write a equals here. If you're saying area equals, I would write out the word area. Or save these as something else. Right? Do you see what I'm saying? Like lowercase a or something. So I would write out the word area instead of writing a equals, because that's just confusing. We don't do that. All right, and then we do math 9. So anybody have it? You could even do your y1, y2.
1.095.
1.095. Did we all get that? Yep. Katie?
So on this one, you use both like just the x values for like the
Mm-hmm.
But on the other ones, you use the y values, right?
Nope, I used x values. It's x to x so far. I'm going to use the y's when I have a right to left thing
I
going
said
on.
on like number 3 because x was like positive and negative 1.
Oh, okay, because that was the point. It would become a 1 anyway. So what I did is I did 0 to 1, and then I did 1 to 2, like the x-axis. Yeah. Tricky. All right. Oh, what else would you get points for your setup? What if I decided I wanted to go 0 to a? What could I do if I did 0 to a?
The even things would be 2 f of x.
Yeah, you'd have a 2 out front. So you could also do your setup that way as well. Isabeth? You don't actually need the B on this one. So this was useless, but what I'm saying is like when you have the free response questions on the AP test, a lot of times there's a part A, part B, part C, part D, and maybe like part D uses the Y value instead. So I would go ahead and store that whenever you find an intersection point. Just write it on your paper somewhere so you have it, okay? And store it. Okay.
There's no way they would ask us to find an intersection or something like this on the non-calculator, right?
No, yeah. That would just be torture. All right, here we go. So it says find the area of the region bounded by the curves y equals sine of x and cosine of x between 0 and pi over 2. Where are sine and cosine equal to each other? Pi over 4. Yep. So this is pi over 4 right here. So where do we think pi over 2 is? Well, let's think about cosine of pi over 2. So cosine is the red curve on my paper. So this is the red one. So what's cosine of pi over 2? Think about your unit circle.
0.
It's 0, so it's crossing right there. Right?
The red one is...
The red one's the one that started on the top and went to the bottom, and that's the cosine curve. So this is crossing at pi over 2. So if I'm finding the area of the region that's bounded by these between those two x values, can you guys see what kind of shape it is? It's like a little bow tie, kind of. It's like here, and then they cross, so it's going to be here. So that's confusing for students because they always think it's like this triangular region. I said nothing about the x-axis. Like I didn't say it was bounded by sine, cosine, and the x-axis. Do you guys see that? Okay. So sometimes it can be tricky on area because there are different pieces that are formed. So you need to be very specific about the wording. So on the homework, sometimes I say like the little triangular, air quotes, piece formed by these two curves and x equals blah, blah, blah. So look for things like that. All right, so if I'm setting this one up, the top curve was cosine at first, and then I have the bottom curve as sine, and that goes from 0 to pi over 4. And the second part was pi over 4 to pi over 2, and now it was the top curve was the blue one, sine of x minus the cosine of x. Ariana, you finding it for us? The pressure. I think they're the same. They look the same, right?
They should. I think they should.
414. Okay. And what's the second one?
The total is...
You can't do this add together? 414, 414. You got this. 828. Ariana. That's funny. She was really going for it, though. She wanted to get the right answer for us. Yes, definitely. All right. So, yes, 0.828. So basically, the actual answer, if I did this by hand, it would involve a square root of 2. Like this number here is 1 minus square root of 2. That she had up there was 1 minus square root of 2. So 1 minus square root of 2 plus another 1 minus square root of 2. So I think that's 2 minus 2 root 2. Let me check. 2 minus 2 root 2. Do you guys see why you would have a... Oh, maybe it's 2 root 2 minus 2 is actually what it is, yeah. Okay. So let's do a right and left one. Are we ready? Can we rise to the challenge here? Now, every year I have some smarty pants in my class who just decide that they are just going to mess with things. And they're just going to, instead of having x, like x equals y squared and x equals 2 minus y squared, they're just going to rotate everything. And they're going to be like, oh, I have instead y equals x squared and y equals 2 minus x squared. Please don't do that. It will lead to lots and lots of confusion when we get to volume.
Is it correct?
So as tempting as that is sometimes, but it messes with your intersection points sometimes, yeah. So I would not do that. So don't just switch your variables. Do it the correct way. And on the AP test, remember, you get all these points for the correct setup. And if you're just deciding you're switching all your variables around, you're not going to get any points for your setup. So out of a 9-point free response question, you would get 1 point. Please do not do this. At most, yeah, if you got it right, right? Okay, so we're going to do the right minus left thing. So remember, we just talked about that. We said if I have 10 to 4, then this distance is 10 minus 4, which is 6, right? So we're doing the right curve minus the left curve every single time. But previously, we went from x value to x value for our limits of integration. What do you think we're going to do here? Y value to y value. So when I integrate with respect to y, I'm going to have a dy at the end, and I'm going to have y values here. And then everything in here will be y's as well. Everything's going to be changed. Like, we're going to have y's for everything. Do you guys understand? So our limits of integration, which were previously like x equals 2 to x equals 5, are going to be y equals to y equals. We're going to have y's and y's. Good? Okay. Can you tell which one's which? The right curve, what do we think the right curve is? Is it y squared or is it 2 minus y squared? Nope. 2 minus y squared, 50-50 chance, right? 2 minus y squared. So it's x equals 2 minus y squared.
Which is 2 minus
And then the left is the x equals y squared. It goes through the origin, 0, 0.
How can you tell?
So if you can't tell, I would do a quick t-table for them. So if you plug in numbers for y, right, you would get numbers for x. So if I plug in y equals 0, I get 0. If I plug in negative 1, I get 1, 1. So I should have the point 1, 1, 1, negative 1, 0, 0 on this first one. Did you see it? So you're just doing a t-table, but you're using like your independent variable. Your thing that you're plugging in for is going to be the y value. Okay? All right, so we're going to do the right minus the left when we set this up. And our right curve was 2 minus y squared, and the left curve was y squared. And our y values, if I shaded this area, what two y values am I between?
1 and
Negative 1 to 1. Yep, negative 1 to 1. Those are y's. Ian's making sure that that is shaded really good there. Okay, what do we got? So you can do this one by hand. It would not be that hard. You could also do the 2 times thing. Like, since it's symmetric on the top and the bottom, you could do 2 times and then do 0 to 1. Who's calculating? Ariana's the only one calculating. Marcus, are you calculating it? Yeah, you got it for me? Did you do it by hand?
Yes.
Ah, by hand beat the calculator. Do we agree? It is 8 over 3. You are correct. Good job, Ian.
Well, you just have to find 1 and then you just double it.
Yep, exactly. You could do 0 to 1, right?
I didn't even think about it. I actually did the whole thing. I wrote the negative 2. I just
And then you realized it after.
So
Don't you hate that?
You're doing the long way.
Well, not all of them are symmetric.
Sure, but like, yes, but this
Yeah.
was.
So Ian said he was able to do it quickly by hand by doing what I was just talking about, where you find it instead from 0 to 1, and then you double that area, right? So you can do that as well. All right, so number 7. So it says find the area enclosed by y equals x minus 1. So that's a line. It has a slope of 1, so up 1, right 1, up 1, right 1. And then now we have this weird one, y squared equals 2x plus 6. Ugh. This is where it gets hard to graph. So you can use your calculator, but when you use your calculator and you take the square root here, you're going to get plus or minus the square root of 2x plus 6. Okay? And you can plug in different numbers if you want to. It is a parabola on its side. What do you mean square the other one? Oh, like do a system of equations to find their intersection point? Yeah, you can. So let's say we do use our calculator for the intersection point. Remember what I told you, if you're finding an intersection point, you have to set your equation, your 2 equations equal to each other. So we would do like x minus 1 equals the square root of 2x plus 6, but we would also do x minus 1 equals negative square root of 2x plus 6. So we can use our calculator, or you can graph it by hand. This one's a little hard because the 2, it's hard to come up with values. Oh, is my calculator not working here? It's not letting me clear. Let me go back in. So let's put the x minus 1. Yeah, Ian?
No, nothing. Sorry.
And then we do second square root 2x minus 6. And then negative square root of 2x minus 6. Okay, so we're going to have a top part of a parabola, right, like a square root function, and we're going to have the bottom square root function.
So did you do like the
Ooh.
positive one first?
Oh, did I do minus 6? Okay, hang on. 2x plus 6. I made a mistake. They didn't intersect at all, so I knew something had to be wrong. And then what were you asking?
Did you do the positive one first and then like later on the negative?
Yeah, I did both, yeah. So are you to find the intersection point, you do both equations?
Well, yeah,
yeah?
but I mean like, no, you can't do them both at the same time.
No, so like I did one for y2 and one for y3. So I separated them. So then I would do my second trace and my intersect.
Did you get 5 comma?
I don't know, hopefully. Did you guys get 5 comma 4? Yep, 5 comma 4. You already got find the other one too? Ian's my human calculator sometimes. He takes care of me. 5 comma, oh, it took us back there. Okay, so let's go second trace, intersect. And this is a little bit tricky sometimes because notice how it's going along this curve. So I want it to be along that curve, so I'm going to hit enter. But I got a little bit too hasty and I just did enter again. I need to actually go down to the other side. So you see that blinking light, how it's on the top curve? I need to go down to the bottom curve. So I'm going to arrow down, and now I'm on top of it, and now I can do that one. So negative 1 comma negative 2. Where was it? Negative 1
Negative
comma.
1 comma negative 2.
Yeah.
Negative. The line doesn't go to negative 1 comma negative 2. Oh yes, it does.
Yeah. So I had to arrow down to that other curve again. All right. So now here's what we got. So we're going to do the right minus the left. Now, whenever we're doing right minus left, we have everything in terms of y. So we're doing right minus left. We need to integrate. So you'll see me write this sometimes. Integrate WRT. What that means is with respect to. So integrate with respect to y. So we need everything to be y's. So when I talk about my limits of integration, this was the point negative 1, negative 2. My limits of integration are going to go from negative 2 to 4. My y values, right? How about the other stuff? This gets a little bit weird. When I talk about my right side, that was the line y equals x minus 1, but I'm not going to write x minus 1 here. I need everything in terms of y. Yeah, y plus 1 is equal to x, right? So I'm going to say y plus 1.
Minus.
Ah, good. Y squared minus 6 over 2 is equal to x. Do you guys see how she got that? So subtract the 6 over and then divide by 2. This is where students have a hard time because they always want to put the x's in. Remember, we're doing right minus left, which means we're going to use y's. So I'm going to have that y squared minus 6 over 2.
Can we just math 9 this one?
Yeah, you can math 9 it. Now, every year students are like, wait, so math 9, how do I do y? You can do alpha y if you want to. I would just use x in this case. As you're putting it into your calculator, like I would just do math 9 and hit the x button instead of hitting y button. It's just any variable, right? Yeah. Do you get it? Oh, you're good. What did we get? 18? That whole thing came out to be nice 18? Yay, I like things like that when it ends up really being so nice. Not all the time, not like all those textbooks, but I do like things like that. Sometimes we do calculus recipes and we make things. We'll have to do that
Like
sometime.
actual food.
We do. We make food, like pancakes or what else have I made? Pancakes is the main thing we do with this one. And so it's when they end up nice like that. So 18 cups. It would be 18 cups. That's a lot. All right. Are you guys understanding this? Do you guys feel like you can do your homework now? So right minus left, you're feeling pretty good? So yeah, we just have that one more. It says, what would we need to do if integrating with respect to x? Like you could do that last one with respect to x. It just gets really messy because it would be top curve minus bottom curve. you'd have to break it up into portions. So like mine is not drawn very well. Let me look at the calculator. So you'd have the top curve as the square root 1 minus the bottom curve until here, the intersection point, and then you would do top curve minus bottom curve. So let me draw on here. So this part would be top and bottom, and this part would be top and bottom. So you could do it, just much messier. Okay?